And now to welcome to the stage a dear friend also from the UK, Mr. Suhail Patel from Monzo.
We're just going to set up, and then we should be ready to go.
Great. So, Mr. Suhail Patel.
Thank you very much. Assalamu alaikum and shukran all for coming down. It's a real honor to be standing in front of all of you here today in your wonderful country of Jordan and such a beautiful location for Xpand itself. Now, we obsess over user experiences when we ship our products to customers. We want the best user interface, we want the most reliable products. We build our products, because ultimately that impacts revenue. But we often neglect the sharp edges and organizational bureaucracy in our own tools and processes that get in the way of valuable human cycles. And these slow us down from delivering all of these wonderful products to customers. Now, by way of introductions, I work at a company called Monzo. We are a fully regulated and licensed bank in the UK. We have over 9 million customers who use us daily for all of their banking needs, and that is growing absolutely rapidly. And we are a leader in fintech circles because of our usage of technology to simplify what we do with our product. Now, as I'm sure many of you will attest, banking is a really complex industry, and we undertake the complexity in our systems so that customers have a better experience. Nobody really wakes up in the morning and it's like, you know what I'm going to do? Yalla, I'm going to go to my bank because that's the first thing I want to do this morning. But we want to change that dynamic. We want people to feel excited about when they are interacting with their bank because ultimately that is what's holding your money. That's what's holding your ability in society. So we want to shift that by giving you tools to do budgeting, to do financial planning, to understand where your money is going, and ultimately have a really great product around the usage of money. To facilitate this, we are an online-only bank, available 24/7 through the mobile apps that we provide, because we firmly believe in today's day and age, there's not really a need to go into a bank branch. We maintain an API of all of our physical branches, and it's one of the most simple and most reliable APIs we've ever had over the last 10 years, because it's forever returned an empty list. All of our branches are only on GitHub. For me personally, hi, my name is Suhail, and I am one of the staff engineers from the platform group at Monzo. I work on the underlying platform, powering the bank as an individual contributor. We think about all of the complexities within the platform group of scaling our infrastructure and building the right tools so that engineers in the right teams can focus on building all of the features that customers desire. What we do within our platform group is we provide an opinionated microservices platform built on top of Go and Kubernetes and many other open source components like Kafka and Cassandra, all on top of cloud providers like AWS and GCP. We're one of the first banks in the UK to go into the cloud. Here is a connected core graph of all of our microservices on the screen. There's many, many dots. We have over 2,800 microservices, and each dot represents a service and the communication lines between services. We rely heavily on standardization and automated tooling to help build, test, deploy, and monitor and iterate on these microservices. We only have about 300 engineers at Monzo, but we have over 2,800 services to power all of the complexities of running a bank. We have a running joke, which is as an engineer joins, you get allocated your 10 microservices, and you have to tend to them and water them and look after them and make sure that they're running and healthy. Actually, in reality, we rely heavily on automated systems to make sure that this can continue to scale. Now, just to lean into that complexity a little, a common question I get asked is, 2,800 microservices to run a bank. Isn't that a little bit excessive? And on the slide is just a small subset of all of the different payment integrations that we need to build and support for. We build a lot of our own technology stack, so we maintain our own financial ledger, and we build direct connections with all of these different payment schemes. Now, a lot of these logos may seem unfamiliar in this part of the world. These are all different payment schemes that exist in the UK for interacting with money. And as I'm sure many of you will attest, some of these payment schemes are quite old. Still rely on moving files via FTP or sending an Excel spreadsheet at the end of the day. A lot of people think that the world of banking is just like a highly resilient and a constant. There's a lot of consistency and durability and reliability in their systems. And when they look at the reality is just reconciliation at the end of the day. At the end of the day, the numbers need to add up. And that's what all of these payment schemes facilitate. But for customers, imagine that you spent a bit of money and that money only showed up at the end of the day. You'd be worried. It's like if you sent someone else like £1,000, that's a lot of money. You want to make sure that that is visible on the other end. So we undertake all of that complexity on our side without surfacing the internal complexities of all of these different payment schemes and reconciliation and effectively limiting our product offering and our user experience. Now, internally, one of our most ubiquitous tools is across Monzo is our Monzo command line interface, the Monzo CLI, or internally we call it the pound CLI because we use the Great British Pound in the UK. And the Monzo CLI allows engineers to call into any of our backend services in production, and they can manage service configuration, schedule operations, interact with some of our infrastructure, and much, much more. For example, I can type in a user ID and get all of the information relating to that particular user from our various internal APIs that we surface. Now, I don't need to go and look up these individual APIs and then come out with an access token and do some authentication dance and go into Postman or whatever the tool is and craft the perfect HTTP command or learn curl or do all of this stuff. All of this is really easily accessible within an easy-to-use CLI, and we've got a lot of internal APIs, APIs that are not surfaced to the rest of the world that power all of this functionality. And within the CLI, we've got particular functions registered. So for example, that find command is a custom command that we have implemented to look out, for example, for user IDs and know what API to call. But for example, you could type in a transaction ID or a merchant ID, and the system will go and figure out what type of ID it is and call the relevant API and print that specific context. So for example, here I've used it with a particular merchant ID, and I automatically get information about the merchant itself. Now that CLI has all of that knowledge baked in based on what IDs are what, based on what internal API sources are available. And what this means is that when an engineer in another team adds a new payment scheme or introduces a new piece of functionality, for example, like a marketing message or a push notification or a text message or an email notification or something like that, that is automatically embedded into the CLI so that any engineer can go and look that up. And we can surface that across the company. Now, these tools do not function in isolation. Behind the scenes, a lot of machinery kicks in. On our backend, we routinely do authentication and authorization for all of our APIs to make sure that you only have access to the data that you're allowed to have. For the scope of your work, for access control. And we log all of these authorizations for auditing purposes, as you would imagine. Sensitive actions don't just automatically get surfaced to the entire Monzo community, so we have some level of control. And if you're trying to access something which you shouldn't have access to, we will create a task to go and review that, and then you need to go and get permission from someone who does have access to that to make sure that you're not giving away information willy-nilly. Now, what this means is that we empower engineers to go and deeply own their own internal systems and production data, because it's not just about flinging your systems over the fence without regard for the data. And what we do is we maintain a secure and a reliable tool and security controls so that information just doesn't leak out across the company. Now, if you were inclined, you could, for example, craft all of this, using API tokens, find the right API, like I mentioned originally, craft the right JSON payload, parse the output, and rinse and repeat. But imagine you're doing that in the heat of when something has gone wrong, in the heat of an incident, for example. All of that is just additional overhead, additional complexity that you need to maintain. In other companies, I've seen engineers maintain a really long text file of all of these different bash commands that they've got saved. And when they want to go and find something, they find their artisanal bash command and substitute the right ID and do all of this song and dance and then go and paste it into their terminal. But that is not scalable. That is individual to one engineer and their particular workflow. And we want to build a tool that is ubiquitous across all of engineering and disciplines beyond engineering. Now, using the CLI, we have different modules. It's not just about looking up data. We want to expose other bits of functionality as well. That might constitute usually a chain of requests. So imagine that you were doing this in Postman or your favorite API tool. This would be multiple commands that need to run in sequence. You take the output of one and input it into the other. But we take care of all of that through our CLI. For example, configuration management, which I'm showing on the screen for our backend microservices, is all handled via this CLI. Engineers can set specific configuration keys and request peer review for really critical services and sensitive bits of information. Now, I see many power users proud of their command line history, but this makes this sort of system available to all of engineering. Whether you've just joined, that means that you can safely go and change configuration and make sure that there's validation and everything happening behind the scenes, both locally and on our backend systems. And as I mentioned earlier, authentication and authorization is taken care of for you because we expose all of this thing through our internal APIs. Now, I've focused a little bit on our CLI, but there's a really wide range of tools that we provide to our engineers. Things like service queries. So, I mentioned earlier about this 2,800 microservices. You need a tool to be able to go and understand what each of our services is doing and go and analyze the endpoints that are available and the history of that service and who owns that service should something go wrong. So we have explicit metadata. I see a lot of companies rolling out things like service catalogs and other bits of collecting metadata, and we use that information. For example, we have Backstage deployed internally, which is like a service catalog system. But Backstage on its own is just a UI visualization tool. But we're able to take the metadata that we encode, the stuff that powers Backstage, and use it to build tools on top. Tools for surfacing that information, for example, like on the command line, like I'm showing here, but also like within our monitoring tools and our alerting tools, we're able to route alerts and issues to the right teams. So as services are shifting between teams, we're able to route it to the right information to make sure that a service doesn't get dropped on the floor. Even for things like mobile development, we have this particular droid command. Mobile development is usually a pretty finicky space. You usually got to spin up an emulator and go and click around stuff. And what we've done is we've taken some of the APIs that Android Studio and the emulator provide and written a Go-based CLI on top to help our Android engineers with easier testing and debugging of the Android app during development. Now, this tool makes it easy to script common workflows, which makes it even easier, especially for folks who are not, really engineering focused. So, for example, if you work in QA and want to go and, write a sequence of steps to go and, click here and do this thing and, spin up the emulator with this particular version and make sure that all this testing is done, you can write now pretty basic scripts by chaining together a bunch of commands using this Droid CLI. Now, let's talk about one more of our CLI tools. It's a tool that we call Shipper. Now, we deploy hundreds of times a day, every single day. On our work week in the UK is Monday to Friday, and there's a common trope in our industry, which is you do not deploy to production on a Friday. And we want to shift that. We deploy hundreds of times a day, even on Friday. People deploy at 5 p.m. and then immediately go home. And that's something that we really highly encourage because the tool, Shipper, helps orchestrate the build and deployment and monitoring process. And we provide the CLI so that engineers can deploy in confidence. Now imagine that you're deploying a microservice that you're not too familiar with. You need to figure out all of its different build patterns and configuration patterns and the way it should be deployed and it needs to be sequenced like this. And we want to take away all of that complexity and encode it into the actual configuration of the system itself and have the deployment tooling take care of it. Because what that means is that we automate the human complexity away. An engineer just cannot get it wrong if they have automated the way that they deploy. To deploy a change at Monzo, engineers effectively develop their changes in their local IDE and effectively have to request a peer review using GitHub. So they create a pull request, and once that pull request is in the mainline, it is ready to be deployed. And we effectively automate all of the entire deployment process away. So that means if you want to go make a change to a microservice, you can make that change in a matter of minutes. And the only real time complexity is the amount of time it takes to for someone else, for the owner of that particular system, to give you a peer review. Once all that code is approved, and we run a lot of CI checks, which I'll talk about a little bit later, once all of that is approved and all the CI checks pass, you are ready to go. You are ready to deploy to production. Behind the scenes, again, Shipper is orchestrating a lot. It runs a bunch of security pre-checks behind the scenes to make sure that you're not introducing code that's going to take a couple pennies from the bank on every transaction. It brings service code from GitHub into a clean build environment to make sure that we own all of our dependencies. It builds all of the relevant container images, pushes them into a private registry, sets up all the relevant Kubernetes manifests, and kicks off a rolling deployment and monitors the deployment to completion. And this is what gives engineers the confidence to be able to walk away because the tool is orchestrating everything. All of this gives confidence to the engineer that the system is guiding them through the rollout of their change. We abstract away all of the infrastructural complexity of dealing with coordinating deployments and dealing with Docker and writing Kubernetes YAML, and all of that is abstracted away behind a set of known, well-understood CLI tools. And what that means is that we have control. We can change how we do things. We can change infrastructural concerns behind the scenes without changing and breaking a whole bunch of engineers' workflows. We see the abstraction of infrastructure, servers, systems, things like Kubernetes and things like that, as a marker of success. Engineers can focus on building a product and not have to worry about infrastructural complexities. My goal is that an engineer can join Monzo and spend years, their entire career at Monzo, without ever having to look at a Kubernetes YAML file or a Docker file. Using these changes, using these systems, we're able to deploy hundreds of times, even on Friday. Now, as a quick tip, something to take away, if you are building CLI tools, really consider writing them in a statically typed language, something that generates a binary artifact. So you can write them in Go, you can write them in Rust, because the binary artifact is really, really important. Something that a lot of teams contend with is, it works in my Python environment, but doesn't work in someone else's Python environment, or Ruby, or insert your favorite language here. Being able to just ship a binary, so for example, I can build a binary, I know that if it works on my Mac, I can ship that binary and it will work in all the other Macs across the company. And not have to worry about Python and Ruby versioning is really, really powerful. And this is especially powerful for non-engineering folks, because it's only one brew upgrade away from breaking your entire Python environment. And it drastically reduces the likelihood of the phrase hearing, "it works on my machine." Now, there's a large ecosystem of CLI tools, things to make pretty CLIs, in both languages, in both Go and Rust, and there's a lot of stuff for Python as well. But I firmly recommend checking out Go and Rust. Maybe it's a new opportunity to learn and introduce a new programming language within your company. We've found a lot of success in writing our CLI tools in Go. We use Go internally for all of our microservices as well, so that makes it quite easy for engineers to get up to speed. A key principle we've had around building our microservices themselves is the principle around uniformity. For the vast majority of microservices that we build, they follow the same template and use the same abstractions, the same libraries, the same tools, and the same infrastructure behind the scenes. And our platform teams deal with that infrastructure and then embed the best practices. So we work as individual contributors and are contributed to all of the layers at the shared core library. So that means that things around like making an RPC request, logging, metrics, our library to interact with databases. There's no such a phrase that I want to hear within our organization, which is, we forgot to instrument that query, or we forgot to add a log line for this particular error, because all of that is taken care of at the library layer. What that means is that engineers are really focused at the purple box at the top, where they're inserting their code. They're filling in the business logic for what they want to be able to achieve, and they're not rewriting core abstractions like communicating over HTTP or marshalling of data or worrying about metrics and things. Obviously, we provide the ability to add custom telemetry as you wish for your business context, but the core bits around communicating over the network and communicating with external parties, all of that is really, really well instrumented. And all of these shared core library layers provide batteries included defaults, like metrics, like logging, and tracing by default. And to achieve this, we use open source tools, things like Prometheus, things like OpenTelemetry and Jaeger and Elasticsearch to run our observability stack. And we invest heavily. We spend a lot of money and a lot of time and resources scraping and collecting all of this telemetry data from all of our microservices and infrastructure. Typically, when companies are looking to cut costs, they're looking to cut down on telemetry data, which I think is a fool's errand, because this can be really, really empowering for your business. And let me assure you, it is not cheap. But every time we have an incident, there's a particular quote on the internet, which is when you introduce microservices, every time an incident happens, it's like a murder mystery. You're trying to figure out what is going wrong, and you're trying to piece together all the different components that have failed, because you've got this inherent thing in the middle, which is constantly flaky, which is the network. So having all of this telemetry, having the right logs and the right level of granularity and tracing and telemetry, all of that gives you the ability to piece together the murder mystery really, really quickly, and then you can shift your efforts towards remediation. To show what this looks like in practice, for every service that comes online, from the moment that you generate a service, you immediately get this wonderful dashboard, which is universal across all of our services, and we have over 100 panels. A lot of them are hidden away in all of these sections, and all of this provides really, really rich telemetry. They can go to a fully templated dashboard from the minute that their service is deployed and see information about how long a request is taking, or what does interactions with the database look like, and how long they are taking. I mentioned a little bit earlier, all of this telemetry also feeds into our backend systems, and feeds into alerts and monitoring. Naturally, as you can imagine, with 2,800 microservices and only 300 engineers, we don't have engineers having all 10 screens, with a dashboard for every single microservice on each screen. Like you see in the financial traders, with their multiple monitors and looking all of these bar charts. We rely heavily on automation to surface all of these as alerts and telemetry and information in real time. So, for example, if we notice an anomaly in our systems, we'll be able to page the owning team and tell them about the anomaly that we've spotted, with really rich and detailed alerts about when the anomaly started occurring and what other things are there in correlation. Now, this telemetry data has come full circle. We have a particular feature in Monzo, which is called Get Paid Early, where you can actually get your salary a day earlier than it's meant to be paid. So if your salary was meant to be paid on Friday, you could get it on Thursday. So that means that the money is in your account and ready to spend on Thursday. And as you can imagine, this is a really, really popular feature. Who doesn't want their money as early as possible? Now, in the past, we've had issues running this service because each time Thursday comes along and we're able to pay this money out at 4 o'clock, there'd be a horde of people effectively clicking refresh and waiting for their money to be available so that they can get paid. We have a lot of customers rushing in. We effectively created the best kind of thundering herd. Now, the problem that we had on our end is that we're constantly iterating on our back end. New services, new service dependencies, and new services in the hot path are constantly being introduced. And what we found is that these services may not be adequately provisioned to handle this peak demand. Now, especially when you have expected load, we're quite fortunate in that a lot of this load is expected load. We know when it's going to come. We know that it's going to happen at these particular times, and we know what the load factor is going to be. So we actually have a bit of time to prepare. But the problem that we had is that we needed to identify these microservices in the hot path and to make sure that they were auto-scaled. Now, we had an option. We could massively over-provision everything, but as you can imagine, that is a really, really costly endeavor. I'm sure AWS would be very happy, our cloud provider of choice, would be very happy taking all of our money, but that would be a very, very costly endeavor on our end. So what we have done is we've used Prometheus and open telemetry data that we emit and store in our systems to analyze dynamically what services are involved in the critical paths of this feature and scale them appropriately each time this feature is provided. So we're able to see how much CPU time it needs and apply a load factor. What this has done is this has drastically reduced the human error rate of engineers individually scaling their relevant services. And it's also reduced the cognitive overhead of us having to go to tens of teams and saying, is your service appropriately scaled? Do you know exactly what is in the hot path so that when this feature comes around, you're not going to have an incident. So this is telemetry data being used full circle, and for us to be able to go and automatically go and scale these things without the involvement of all of these other teams and without the coordination and organizational overhead. This is really, really important because a lot of these services are involved in really, really critical flows. So for example, take, a card payment. A card payment has to be really, really reliable. Right now, I am here in your wonderful country, and I'm able to take my Monzo card and pay anywhere within this country, and it's a Saturday in the UK. So that means that people are enjoying their weekends. We want to make sure that we don't take down our critical services. Quite a few distinct services get involved in real time when we make that transaction, when we make that card payment, to contribute to the decision on whether that payment should be accepted. So we use tracing information to determine exactly where those RPCs are flowing and how long they contributed to the overall decision time, and how many database queries were involved, and much more information. So back into the development loop, we're also able to surface that, for example, this card payment that you're making, you're maybe touching a service which would be involved in a critical path. This would be a critical process within the company. So when an engineer is proposing a change, for example, on the services to the right, the ones that are colored in, we're able to directly or indirectly mention, for example, on their pull request that just a heads up, you're changing something on the critical path. Please make sure that you've got this thing properly tested and well understood and well maintained. And it's one less information for engineers to maintain in their head. For example, if a new engineer joins and they're making a change in a microservice which is 4 or 5 connections down the line, they might not have that immediate context right from the get-go, right from day one, is that they're making a change in a potentially critical path, right? And if they're unsure about it, they can't just YOLO it into production. They've got to make sure that their change is well tested and well understood. And this core graph is constantly changing as we continue to add more and more features. So this core graph used to look really, really simple, but of course, as things have gotten more complex, the world has gotten more complex. We've had to introduce more financial crime controls and machine learning models and a bunch of other stuff. And this service core graph has gotten really complex, and it's still something that we need to serve in a very, very small time budget and needs to be really, really reliable. As I mentioned earlier, a lot of our microservices are written in Go, and one thing that we've really standardized on is following a consistent file or folder structure and as a common pattern across the company. So we have a service generator that generates all of the boilerplate code within a single command. If you remember a few slides earlier, where insert code here, this generates all of the boilerplate. What this means is that we have a single repository for all of our microservices. You can jump into any folder and feel like you're in an area of familiarity. And what that means is that we can write tools that scan over our entire repository. We can write them once, and we can surface all of the issues on the fly, and sometimes even rewrite code. One of my favorite tools, to help facilitate this is a tool called semgrep. If there's anything that you take away, go check out semgrep. Semgrep is an open source tool that allows you to write static analysis tools. It's a bit like grep if you've used grep in the past, but it understands a wide variety of programming languages. So let's say that you've got a bit of Python code and you want to, for example, encourage people to use logging.debug rather than using print. Then you're able to encode it in a static analysis rule like this and run it across your entire code base really, really quickly. And this is extremely helpful when you're running this as part of CI checks. Now, static analysis is a really, really powerful tool to build a code base towards a particular convention and to have some element of consistency. Introducing a new rule helps stop further additions of something that you want to deprecate or move away from. You could then track and focus on removing existing usages and then making that rule 100% enforced. This is how we roll out significant logic improvements in our entire code base at scale across all of our microservices. This is extremely powerful because if you have a particular bit of code that has contributed to an outage or an incident, learning from incidents is really, really key. If you consider adding that as a static analysis rule, it's a great form of documentation about why you've moved away from something, and it also allows you to keep track of all of the places where that particular pattern might be used and places that you want to discourage or clean up. Now, all of our, as I mentioned earlier, code and services is contained within a single repository. And what that means is that we avoid a lot of dependency and rendering hell, and also allows us to do cross-service changes with ease. So if we have a particular pattern that we want to disallow or a particular pattern that we want to encourage, we put in a static analysis check. And this allows us to identify issues at scale before they get in front of customers. Before we make these static analysis checks, required checks, we make sure that we clean up existing use cases and the existing code base so that engineers are not tripped up by failing checks. One of the biggest signals that I've seen from engineers is when you get a red cross. And when the red cross says that is not a part of a required check, what do you naturally do? You ignore it. You don't look into it because it's not part of a required check. This means that we give engineers a high-quality signal rather than engineers ignoring checks. Because there's all of these frictions, all of these little paper cuts and broken windows that we want engineers to avoid. We want to make sure that we encourage the right behaviors and engineers take the path of least resistance. What that means is that if you see a red X, that is a sign of a legitimate issue and one that should be investigated. Code generation is another area which we focused heavily on. For example, we use protobuf, and RPCs can be specified as a protobuf configuration. And what that means is that we use the protobuf configuration to generate all of the boilerplate code in Go associated with an RPC. And we've written generators on top of the protobuf library to help generate our service HTTP code. And within this definition, we also allow for introduction of validation checks. So for example, you can say that a particular field is required, and we generate code to do automatic validation checks for all of our APIs. So what that means is that, in terms of an engineer writing a service, they're writing maybe 500 to 1,000 lines of actual code. And that kind of size is really understandable for a bunch of engineers to write and review. Which is really, really important. It allows us to move really, really quickly. And combined with the uniformity aspect that I mentioned a little bit earlier, when we make a change or optimization in our RPC library or any of our shared core library layer, we're able to roll that out across our entire estate so that everything benefits. And this can be as simple as just regenerating service code and naturally using tools like Shipper to automatically roll it out to all of our services. And what that means is that this breeds a really, really strong culture of continuous improvement. Earlier on, I talked about the approval, the authentication and authorization system of our Monzo CLI. Many RPCs are sensitive. We don't want to just surface information about all of your raw card details, even to an engineer who is investigating an incident without some form of authorization, especially in production. Some of these things should be completely forbidden. We encode this information into our service definition so that they are explicit, and we showcase when you need to go through peer review. Our authorizations in our backend check these service definitions every time an RPC call is being made by an engineer, verifying and logging exactly what has happened, and generating a review if a request needs secondary approval. So within protobuf, we've added an option, who can RPC, and engineers can specify whether their RPC should require a secondary person before it executes within that RPC definition. And by default, we run all of our RPCs in a completely block-listed way. So engineers cannot execute an RPC until it is allowed listed. So here, we've said, okay, you can only call this RPC if you're a contributor to this service, but you can only do it with approval of someone else. So that means a random engineer can't just go in, even if they had approval, and make this particular RPC. So that means that we're able to retain oversight and security and controls even across our microservices estate, whilst providing control to the teams that are building the systems, because they understand all of the owning context of what that RPC surface is. Now, lastly, let's touch upon developer tooling for measuring performance. Now, the founder of Shopify had this really wonderful and long Twitter rant a couple of days back about why performance matters and why it is typically not owned by product leads. Now, extremely rare that you'll hear a product person saying, they'll put a ticket on the Jira board, which is, reduce latency of said service by 10 milliseconds, and let's say it's actually going to serve a product metric. And the quote in the middle there is the important one. Not all fast software is world-class, but all world-class software is fast. A lot of our software relies on powerful compute happening elsewhere on our backend systems, or communicating to a server somewhere, and we often don't consider what happens with spotty cell phone signals and things like that. Now, if every mobile interaction has to do a round trip to a server somewhere, what happens if you temporarily lose connection or it becomes slow? Compounding to that is the amount of time being spent on our backend systems themselves. If they're spending 5, 10, 15, 20, 30 seconds in some cases, you're going to lose that if you're, for example, traveling on a highway and you're in a car. And what that means is that request, all of that compute time has been spent doing something which is effectively now redundant because the response cannot be sent back. There are really great tools to help simulate this effect, and I don't see a lot of engineers really leveraging these. If you're on a Mac, the network link conditioner, which is a tool that comes embedded as part of Xcode, is really, really good. You can help simulate slow bandwidth, for example, and more crucially, what happens when packets are dropped or delayed. For backend systems, most performance profiling tooling is usually locked away under lock and key because it requires special privileges to run. And very few organizations give the ability to engineers to run profiling tools in production because they add a little bit of overhead. And I think this is a fool's errand. I think this is not a good outcome. This attitude needs to change. You need to have the capabilities across a broad range of engineering to observe systems in production. Many languages provide out-of-the-box profilers that basically add zero overhead to be able to profile your systems in production. For example, Go, which is the language that we use, provides profiling tools which you can turn on with basically a single line of Go. And you can surface it using a HTTP server. Java has had some really great performance tools in later versions with Flight Recorder being embedded directly. Putting all of this into a language that business folks will understand, fast systems lead to happier users and, of course, less compute consumption. What that means is less cost. We have a Slack channel internally called Graph Trending Downwards. Slack is a communication tool that we use internally. And that tool is where engineers can post their successes, areas that they have optimized, areas that they have made faster and better, stuff that they've been curious about. And we have the entire engineering community, but also people from outside of engineering celebrating those successes because of how important we see it as a company thing. It's an ability to brag a little, humble brag, we call it, and celebrate these successes as a company and as a discipline. Now, a lot of this presentation has been around technology and software and systems, but core part is the organizational aspect too. You can have the smartest engineers, but not be able to leverage them effectively because these engineers and managers are not incentivized to push for that investment and the upkeep of systems and tooling. Now, we have the concept at Monzo about the paved road. This is the King's Highway in Jordan. I had earlier another image of the paved road, which I think was shown in the previous talk. And it's a key reason that the paved road is a key reason why we've not ended up with over 2,800 unmaintainable services that all look completely different. An engineer needs to be able to jump into a service and feel an air of familiarity. And this starts from day one of an engineer joining. We want to get them on the paved road as quick as possible through a series of documented steps and onboarding procedures. And we provide a support structure to be able to answer all sorts of questions from everyone who's been there within the company. And engineers can rely on a wealth of shared expertise. We have found that onboarding is the perfect place to seed long-lasting good behaviors, ideas, and concepts. And it's much harder to change bad behavior once someone has become used to it. So we spend a lot of time on the onboarding experience for engineers. Now, the paved road shouldn't make it feel like you're stuck, and you need to do things in just one particular way. The most dangerous phrase in a software company is, this is how we've always done it, or we don't build software like this other way. For example, at the end of 2019, we migrated a faster payment system, which is like a payment connection system that runs in our data centers. We built our own in-house system, and we decided to not use microservices for that particular system. We made a very conscious choice because we wanted a simple, easy-to-deploy artifact in our data centers, and we didn't want the complexities of running Kubernetes in our data centers. And we have a blog post on the specifics of that particular migration. So yeah, we wanted to really focus on the durability and reliability aspects of this component, and it was scoped. We knew exactly what we wanted to build. We knew what minimal code we needed in the data centers to help do the actual decisioning of that faster payments logic into the cloud. Coinbase, for example, put out a really great post in 2020 about why they were not adopting Kubernetes, for example. And they talked about cost of ownership and a bunch of other developer tooling and efficiencies and things like that. But in 2022, they put out an updated blog post about why they changed their course, which assessed how the landscape had changed, how it had matured, upgrades and maintenance and managed offerings. And the conclusion that they came to is that their original concerns were no longer warranted. So it's important to constantly reevaluate whether the paved road that you've put out is still appropriate. We can't ignore the elephant in the room. AI and large language models are huge enablers for engineers. So much of our time as engineers is spent searching for information. Also, by the way, if you disagree with this list of the best shawarma places in Oman, I'd love to have a chat. I've come here just to eat shawarma, so yes, I'd love to hear what the best is. If you've not played with it, GitHub Copilot is absolutely incredible. I was amazed at the high quality of code recommendations and the explainability of just highlighting a piece of code and being able to ask questions and explain to it. It's almost like having a rubber duck, someone with eyes, looking alongside your shoulder and helping you along the way. We are using it at Monzo internally, and we have hundreds of thousands of lines of code being accepted per month, and that is growing rapidly. The space around automated code development is rapidly changing. Tambi talked a little bit earlier in his opening speech about code being replacing engineers. I think slightly differently. I think code is here to enable engineers and providing them with new capabilities and enhancements, things which would take a lot of time to get up to speed. For example, I am really good at writing backend systems, I think, but I am really terrible at writing GUIs and front-end UIs. So for example, using this tool called V0, I was able to literally type a prompt, which is generate a conference sign-up form for a conference called Xpand running in Jordan. And it generated this really wonderful form that is ready to go and the code associated with it. So this is going to provide huge capabilities to a whole new group of builders and engineers. A year ago, Bloomberg spent 1.3 million GPU training hours and a couple $1 million in actual money to train AI models because they thought their financial knowledge is going to give them an advantage. As a moment of irony, a couple months later, GPT-4 came out, and it outperformed, there was a bunch of papers around this, outperformed pretty much every financial task compared to Bloomberg GPT. And this is a model that's available to the masses. So let this be a lesson. You don't need to spend millions in getting started in AI and LLMs. A lot of people think that these are buzzwords, but you can, for example, these companies are not willing to spend $10, $20 per engineer and give them a tool which is accepting tens of thousands of lines of code and making recommendations. Imagine that you are asking all of your engineers to write their code in just Notepad, without any IDEs or syntax highlighting. This is how you are hobbling your engineers by not investing in the tools which engineers can leverage today. Don't reinvent the wheel. And even the world of local LLMs as well is really, really fascinating. I downloaded the Meta Llama 3 model, LLM model just before I got onto my flight here to Jordan, because Royal Jordanian doesn't provide any Wi-Fi in their flights. So if anyone works for Royal Jordanian, please provide Wi-Fi onto your flights. That would be really amazing. But this was one of the first times in my entire lifetime working with computers where I felt like I had the entire internet on my machine, on this little dinky MacBook Air. It was really, really powerful. So there's an entire knowledge base open to new engineers for small cost or no cost to many people. And a lot of the companies are skeptical about surfacing and enabling these gains. Now, I've talked a little bit about the wide variety of tooling that we have, and a lot of this did not exist on day one. This investment is continuous and ongoing, and is proportional to the size and scale of our organization. A lot of these tools that I mentioned, like SemGrep and Prometheus and Jaeger, these are all tools that are open source, so built on top of the shoulders of giants. And we reward engineers as part of their progression when contributing and building internal tools and software as well as contributing to open source. This holds merit and weight, just like shipping product features does. So in summary, by standardizing on a small set of technologies and continuously improving these tools and abstractions, we enable engineers to focus on the business problem at hand. So be very, very conscious about when systems deviate, and it's fine if they do as long as intentional and for the right reasons. There's a lot of discussion around platform teams and what platform teams build and their roles in organizations, and a lot of that focus really heavily on infrastructure. See a lot of platform teams being built up as like just the people who maintain the Kubernetes or the servers or the blinking lights over here. One theme that is not often talked about is the bridge between platform teams and product-facing teams, people actually building the code that ships to customers. And bridging that gap can bring a lot of leverage. Engineers should not need to be experts in Kubernetes and Terraform and all these different deployment methodologies. They should just have tools available to be able to allow them to get on with their work. It is really important to leverage delightful tooling that doesn't frustrate, tooling that empowers engineers to go and focus on the problem at hand. Tooling can be an enabler, and it's important to continuously invest in delightful tooling and reward people who contribute to internal tooling right from the get-go. And with that, shukran jazaleen, and for having me here at Xpand.